main topic is colors. Every so often I write these little slides over here. You can think about that. Tell me in the reflection. It's good to think about other things like or not other things. It's important to think about your feelings. So if you were a color, what color are you feeling now? And so after I'm done talking at you, you're going to be having the rest of the time to code. A lot of you have already finished Olympic rings and turned it in. If not, then this lecture should really help you out. The Thursday before, I'll give you really helpful hints so that you can meet that assignment due date and get all your points. Okay. As a reminder, the introductory survey where I ask you your motivations for taking this class and some information about you, please fill that out. It's due tomorrow. Your exit tickets, be sure you have at least 10 sentences in your weekly reflections, because on Fridays over the weekend I will grade them and give you points. If you're a little bit shy, you may not get full credit, and I'll give you a reminder of like, you need to write a little bit more on this, and I'll comment in Google Classroom. Be sure to get that in so that you get full credit. And lastly, the Olympic rings are also due tomorrow. I think Google Classroom sets it to 11:59 p.m. You should turn it in way earlier. If you already finished in class, just turn it in. One less thing to worry about. Go enjoy your weekend. And if anything comes up, be sure to let me know in your reflections, like, let me go and spend the weekend on it, or I want to make it better, Mr. Chan. Hold on a second before you grade it. I read the reflections around this time. Let me know then. Okay, questions around the agenda, logistics? No. Okay, so for today's thing, we're going to talk about color. I'm going to build off the example from the first 2 days, and I'm going to show you how to get specific colors and how colors work in computers and a lot of computer graphics. It's a topic that if you have taken principles, you will have explored. If you want to take computer science principles later, you will be familiar with this topic, and they'll go more in depth on what the actual hardware does. And computer science A, Mr. Simon's class, I don't think you talk about colors much, but it's a fun topic to know. In code.org, if you already got a sense of like things and you want to learn more tools and kind of explore what this game lab can offer, when you sign in on day like 1 and 2, you got added to my code.org section. There, I've enabled this one unit called animation and games. So some of you have found it already and found it super helpful. Like one student worked on these lessons and then did Olympic rings and found like, wow, that was really easy. And this kind of focused on a national flag within the first like day. So if you ever need something to do, these are guided lessons from code.org. Work through these and they show you and use the same exact tool as you. Click through them, watch the videos, try out their experiments. One note about this is it previews a lot of concepts that I will talk about later. I do things in a little bit different order, and you should know that the sprites that they talk about in Game Lab are completely optional. You don't need to like know how to recreate those at all. But if you want to play around with them, they do look kind of neat, and you get to animate them and all that. So that's like extra optional fun you can have. But anything that isn't sprites that they use, you will see again. So you may want to work through these on your spare time, and you'll feel confident in your coding abilities, especially those beginners. This code.org stuff does a really good job walking you through those steps, okay? So that's another resource for you to work on. Okay, back here. I'm at my slides, and we'll get here with this color. I may show this video, I may not. But let's say Emilio, a student in this class, he shared in his reflection colors of the specific Olympic rings. As students here, you have the great eye for detail. So some of you noticed like the slight overlap and then non-overlap in the rings, and you're like, how do I get that? Emilio was really aware of like the colors. I want that specific black, yellow, blue, green, and red. And then how do you get that? And I was like, oh, that's great. Emilio took the initiative to find like this specific color. This website that is a great introduction to like very specific colors. And so over here, what is it? Where do I click? Where do you go from here? It's my first time clicking on this. It looks different. Okay, but basically, if you look at the slide, if I scroll down, I guess. Yeah, if I scroll down, it gives you a bunch of numbers. 0, 133, 99. It gives you even like decimal numbers, CMYK, 1, 0.333, 0, and 0.29. Blue, finally something I recognize. And then what the heck is this in hex? Okay, I want this color though, and I want that color, this color, this color, and that color. So a lot of this sounds like gibberish. What I want you to focus on for today are these values right here, R, G, and B. So these represent red, green, and blue. And then it represents on your computer, imagine having a little light. Each pixel has a certain amount of red light, green light, and blue light. And this tells us how bright each specific color it shines. So in this example, to get a blue color, you get no brightness on the red part of that pixel. You get a lot of green, or a good amount of green, 133, and a lot of blue to get this specific shade. And when those colors turn on, you see this shade of blue. So that's what these numbers represent. The values for this, for like the red value, green value, and blue value, 0 means light is off, and the maximum number for these are 255. Okay, that means you're at maximum brightness. 0 to 255 is your domain, if we want to be really formal about these numbers. 0 to 255. And that's one way the computer represents color. So in order to utilize this information, so for example, my blue right now in code.org is kind of a brighter blue. That's the default blue that they have. Well, how do I use this information, R, G, and B, 0, 133, and 199 in code.org? Well, let me show you. Under drawing, there is R, G, and B, that block. So this may be new to you. You can actually drag in blocks within blocks. Really? No way, Mr. Chan. You can do blocks and blocks. Yeah, student, you can do functions inside functions. Woo! Okay, so 0, 133, and I think 199, correct? So by utilizing that block, code.org now recognizes that specific shade of blue. And if I were to drag, let's say, this window over and then make it smaller, I can see that, yeah, it's the same. Okay, so that's new. And now you have all the possible colors that a computer can represent. And fun fact, there's actually some colors that the computer cannot represent. And you think if we scroll up a bit, when you click this thing, all these different colors, if you play it around with MS Paint or whatever, there's a lot. You would think that this represents all the possible colors that we can witness, but surprisingly not. There are some browns in here that I think are really hard to find that the computer actually can't represent. If you think back to textiles, clothing colors and dyes, way back when they mixed their own dyes, and those colors existed back then, and somewhere along the ways we kind of lost them. So that was kind of fun. One of the Berkeley professors told me that. I'm like, whoa, that's neat. Questions? No? So that's color in a nutshell. You've drawn some circles. Now you can use your different colors. You're welcome to watch the video, and I think if you want specifically, and here's another tool from a student in my class last year. If you want to have a specific picture, notice here you can get a specific picture, let's say, okay, this is kind of risky. What do I have in my work laptop that really shouldn't be there? Okay, yes, okay. We'll use the internet outage. So here in this tool, it's neat because you can upload an image, and then it pulls up that image, and as you mouse over, it tells you those specific colors. So let's say you wanted to recreate a certain animal for your third assignment in my class. This will be a good tool to get those colors exactly the way you want it. Okay. In summary, computers represent colors in 3 values for now: red, green, and blue values that go from 0 to 255. 0 means lights are off. 255 means lights are on. There's actually more things involved in color, like see-throughness, like opacity, and some other things that I can't quite describe, but there are more. For now, you just need to know red, green, and blue, okay? That's my lecture. It's your time to code. I really hope this thing recorded.